All right, so if you're building with AI today, you know what we're about to talk about. It's one of the biggest headaches out there, hallucinations. These moments when AI just confidently makes stuff up. This isn't just some weird technical quirk anymore. It's a massive business problem. So in this explainer, we're going to break down exactly what's going on and how you can actually start to tame this ghost in the machine.
And that brings us to the core puzzle, right? We've built these incredible models. They can write code, they can write poetry, they can do complex analysis. So why in the world do they sometimes churn out answers that sound so plausible, so articulate, and are just completely 100% wrong? It's a question every single developer has to face. So let's make sure we're all on the same page. A hallucination is a plausible sounding but false statement. And think about what that really means. It's not the AI making a simple typo or a grammatical error. No, it's the AI confidently citing a legal case that doesn't exist or referencing a scientific paper that was never written. The grammar is perfect, the tone is right, but the core fact is a total fabrication. That is the ghost we're trying to deal with.
Okay, so here's our game plan for tackling this. First, we'll dig into the problem itself. Then we'll get into the weeds of why these models guess in the first place. After that, we'll look at the real-world costs, which are pretty high. Then we'll talk about how we need to totally change our evaluation methods. And finally, we'll get into a practical toolkit before we wrap up with the big picture goal here, building AI you can actually trust.
First things first, we need to understand why this is suddenly such a huge deal. As AI moves from a cool experiment to a core part of business applications, its reliability isn't just an engineering problem anymore. When an AI system can directly impact your revenue, your legal compliance, and your brand's reputation, well, you can bet its failures become a boardroom-level conversation.
Yeah, let's be super clear about the danger here. We are not talking about minor bugs or simple mistakes. We're talking about fabricated data. Just imagine an AI inventing a legal precedent in a legal brief, or a medical chatbot fabricating a research citation to back up its advice. These aren't just errors, they are confident lies that can completely destroy the trust in your entire application.
So if we actually want to solve this problem, we've got to understand where it comes from. Why do these incredibly powerful, sophisticated models resort to just making things up? Well, the answer is buried deep inside their fundamental design and how they're trained.
So here's the first big reason, and it's all about incentives. We train these models to be accurate, which sounds right, but it accidentally teaches them that guessing is a good strategy. The analogy on the slide is perfect. Think of a student taking a multiple-choice test where there's no penalty for wrong answers. What's the best strategy? Guess on every single question, even the ones you have no clue about. That's pretty much what our models are doing.
The second cause goes right to the heart of what a large language model is. At their core, they are just amazing next-word predictors. Think of it like the world's most sophisticated autocomplete. This makes them absolute masters of grammar, style, and fluency. But here's the catch. They don't have an internal truth detector. They just learn patterns from billions of texts, and they can't tell the difference between a widely repeated myth and a cold, hard fact. Fluency does not equal factuality.
And of course, the third major cause is the classic garbage in, garbage out problem. If a model has gaps in its training data, if it's incomplete, outdated, or biased, it's going to have blind spots. So when you ask a question that falls right into one of those blind spots, the model has to make a choice. And its programming doesn't really encourage it to say, hey, I don't know. Instead, its instinct is to fill that gap with the most statistically probable sentence it can come up with, even if that information is totally made up.
And this brings us to a really powerful insight. The whole game has to change. We need to flip the incentive structure on its head. Instead of just rewarding correct answers, we have to start penalizing confident errors, and maybe even more importantly, start rewarding models for knowing when to say, I'm not sure. This is a fundamental shift in how we need to think about building and training these systems.
Okay, so now that we know the causes, let's talk about the stakes. What actually happens when these hallucinations escape the lab and get into production, interacting with real users? Well, as you can probably guess, the consequences can be pretty severe. This chart really breaks it down. It all starts with eroding user trust, because once that's gone, it is incredibly hard to earn back. But it gets worse fast. In fields like finance or healthcare, that broken trust can turn into serious compliance and legal nightmares. And of course, all of this just piles up to cause significant, lasting damage to your brand's reputation. All right, this brings us to a really critical point. If our goal is to stop all this guessing, we have to completely change how we measure success. The old way of just looking at raw accuracy isn't just not good enough, it's actually part of the problem. We need a whole new way to think about AI evaluation.
This slide really lays out the shift in mindset perfectly. The old way, focusing on accuracy, is like grading a test on only the number of right answers. The modern approach is way more like grading the student's entire thought process. It asks not just, is the answer correct, but also, is it based on facts? Does it make sense? Is it actually helpful? And most importantly, it gives the model credit for knowing when not to answer. It rewards uncertainty.
So now for the really practical part of all this. We've defined the problem, we know the causes, and we have the new mindset we need to solve it. So what do you actually do? Well, let's get into a modern toolkit of actionable strategies you can use right now.
We can basically boil this down to a 3-step cycle. First, you have to evaluate your AI, not in some sterile lab, but in messy, realistic, real-world scenarios. Second, you have to get serious about your prompts. Treat them like production code, with versioning, testing, the whole shebang. And third, your job is not done when you hit deploy. You have to monitor the AI continuously, in production, to catch these problems as they happen.
And the good news is, modern platforms are being built specifically for this life cycle. For example, tools like Maxim AI provide capabilities that directly map to these best practices. They offer evaluation workflows to handle that crucial agent-level scoring. They have prompt playgrounds for systematic engineering, and they provide observability suites with tracing so you can see what's happening live. This isn't just theory. These tools are out there today.
Okay, let's bring this all home. The path forward is all about making a shift from just building capable AI to building trustworthy AI. It's about creating systems that are not only powerful, but are also reliable, transparent, and built around the user.
So here's your final checklist. And this isn't just a list of technical chores, it's really a cultural shift. It's about moving from building models in isolation to managing a whole system. It's about adopting agent-level evaluation, treating your prompts like code, and creating these tight feedback loops with continuous monitoring and real humans in the loop. This is how you build a resilient, trustworthy AI operation.
And if you take one thing away from this, let it be this. Dealing with hallucinations is not just another bug to fix. For any organization that is serious about the future of AI, building user trust by shipping reliable systems, well, that has to be priority number one, period.
So, I'll leave you with one final, critical question to think about. I want you to look at the systems you're building right now and ask yourself honestly, with everything we've just talked about in mind, is your AI really ready for the complexities and the consequences of the real world?